Will Eichert is our luncheon speaker. Will has become a good friend of the BIM-M group, and we're pleased to have him back. He's on the board of directors of the BIM Forum that you've heard about. He co-chairs their structural LOD working group for LOD Specifications. He's a founding member and past chair of the Structural Engineering Institute National BIM Committee. So Will, take it away.
Thank you very much, and it's a real honor to get to be here with you. If you can't hear me in the back, I will speak up even further. Let me go rather quickly. Just a little background is that our firm that I work at, we work in building, civil, and infrastructure. We work with a few areas of technology. I am a structural engineer, and we do shop and fab drawings as well at my firm, as well as 3D laser scanning. I'm going to talk why that is relevant in the world of masonry. The other hats I mentioned, Dave referenced quickly. I'm on the group of the BIM Forum. It's already been mentioned here. I'll remind everyone in November in Dallas is the next national conference, and I'll have other things to say about that. I also am one of the founding members of the Structural Engineering Institute's National BIM Committee and had the pleasure of serving as a co-chair on that for quite a while. I am a contributor and speaker with the Certificate of Development curriculum within ISD, and also work with the U.S. Institute of Building Documentation. That is with reality capture. I'll mention a little more about that. Who's heard of USIBD? Okay. Very good. A few here. Where did I begin in this? So, undergraduates in civil, and my graduate work was in 3D parametric modeling in the mid-90s. In structural engineering. I was focused on using the 3D models to also drive analysis, quantity takeoff, and design. And my computer was a 486DX. I had a whopping, on the desktop systems we were using 64 megabytes of RAM. My smartphone has more computer power than my graduate systems I was using, and I was doing a 15-story building. It's taking 13 hours to run the dynamic analysis on it. And I went out into the profession, and my first project was a courthouse in the central part of the U.S., and one of my jobs was 7 sets of shop drawings and manually transferring red marks on the concrete shop drawings. And I went into a deep depression. I felt like this industry would never use 3D modeling. And I knew I had completely wasted all of my graduate money and wasted my thesis. So fast forward that today, I've been really blessed now to be at a company where we work with a number of platforms, and we do shop and fab drawings for literally all aspects of the building. Probably about 20% of our business is doing the reality capture with the laser scanning as well. We use that in the structural systems we design. How many of you have seen laser scanning on your projects? Some hands. Okay. Who has never heard of laser scanning? Okay, some hands. No troubles there. If you've seen, gone to a hardware store, you can get one of the distance measures and you can shoot a laser and it'll give you a measurement. And you can take a measurement, and you can walk a site with a clipboard and a tape measure, and you can measure things. These units now will shoot 1 million of those points a second and go in all directions. And you come back with a 3D capture of those surfaces. Interesting trends and where that's going. So what I want us to think about, though, is if I were to say to you a picture is worth, what would you say? 1,000 words. We already know this. And what's old is new. And it's really, at the end of the day, there's nothing new under the sun. But keep that in mind. A picture's worth 1,000 words. If I were to tell you, measure twice and cut once, you all already know this presentation. You already know what building information modeling is about, and you understand why you need to have it in masonry. So why is it happening now in masonry? So in my graduate work that I originally thought was a waste when I entered the industry now around 20 years ago was that there was 3 things required for an industry to go to 3D modeling. They had to have computer power. They had to have bandwidth to move the data around, and they had to have common platforms that allowed them to transfer these models. I also recognized at the time I was in the St. Louis area, it was McDonnell Douglas before Boeing acquired them. I saw in aerospace, and then at that time I also saw what automotive was doing in other areas of manufacturing. An industry that went to 3D parametric modeling never went back. And that change, when it does happen in our industry, will be unlike anything ever before. It will not be like going from paper drawing to AutoCAD with lines and arcs and circles. This is 3D parametric modeling, and it's a very different paradigm than we've seen before. I could submit to you it's probably one of the bigger changes we'll have in the 50 to 100 year span. And that this adoption, when it happens, will happen much more rapidly than many recognize. And what's going to drive it is this computer power can slip up on you. And if you're not paying attention to things, the technology will evolve around your industry and your firm will be behind, or your industry or your segment. So how many have heard or know of the Cray supercomputer of 76? If I adjusted that for inflation, what do you think it would cost today? It had 8 megabytes of RAM in 76. More or less than $20 million? Do I have 21? Sold at $32 million in today's dollars, 8 megabytes. Many of you, your phones have much more capacity than this. You know, we're in the gigs now. So if I thought about it, and this isn't a great way to compare it, but let's just look at it. It's about $4 million per megabyte. I've seen some 16 gig systems as low as recently this year, $740. You can frequently find high school students with gaming systems in the 32 to 64 gig range of RAM, but we're looking at 4 cents. This gives you some feel. $4 million in 76, 4 pennies today. Things are evolving, and they're doing it very rapidly. Bandwidth did the same. When I finished my graduate work, I was on a dial-up modem, and the whole idea that you could move a model around from one office to another, you had to be a gigantic defense contractor with huge mainframes to even think about this. The fact that you could be a single architect and work with another structural engineer working out of their house and across the country and sharing models was a very foreign concept. And that carried on until we started to see DSL lines come on. But what you're seeing is in the building industry around 2000, we saw the evolution of those 3 things: bandwidth, computer power, and common platforms. Now, there were limits. If you had a lot of detail, the models got big relatively in the 2000s. And then as I looked ahead and I started to watch what is going on with wireless, you're seeing these same bandwidth speeds now go into mobile devices. So the reason the title of this presentation is The Fast Pace of BIM is we need to start thinking. When I was getting out of what I focused my graduate studies on, and what is capable today is vastly different. And I started thinking that BIM is pretty much like dog years. But it's even more strong, it's more pronounced. You know, this is one WebMD. They've got a metric here that equates small dogs, medium dogs, large dogs. But BIM has got to be the biggest dog, because I kind of feel like 1 year equals 30 human years, 2 years is 60, 3 years is 90, and 4 years, well, you're just dead. If your firm has not been keeping up with this and watching what's going on in masonry, you're going to be dead. If you try to come to this again in 3 years, it's going to be a very different BIM world, and your dog will be dead, and you got to just hang it up. Either sell your firm or do something. This gets into so things are moving fast, models are getting bigger, and we're adopting more computer power. We're able to share models with the cloud now. We've seen that in other presentations. And where does this leave us? I would submit to you, who knows what one of the first delay claim cases was? was a masonry job with the Tower of Babel. Now, why did construction stop? Does anyone know? Their languages. They were confused. Now, whether this is a fable or a true story, I submit to you there's truth in this story. Construction stopped when their languages were confused. And this is where the BIM Forum's level of development specification comes in. We have all these models flying around. Everyone's trying to come together and get this building put together in the virtual world. We need to be able to talk about a few things: scope, schedule, deliverables, responsibilities, and liabilities. One part of my firm is working as an expert consultant on litigation cases in the BIM arena. And what I'm about to talk to you in LOD is very fundamental in the contracts that are written well, and those that go into litigation. LOD, I'm finding, comes up a lot because it is the vocabulary that will start to create the common language for how the building will either go together or have a delay claim. So if I went through it, the LOD specification with the BIM Forum has been progressing now since 2012. 13 was the first publication of it. 14, 15, 16, 17 is under development. Public draft will be coming out later this summer and be ratified at the November BIM Forum that I hope to see at least half of you at in Dallas, November 6th through the 8th. I'm going to talk a little bit, some takeaways. This does not tell you how to do a project. Think of the LOD specification as a dictionary. It gives you that common vocabulary of what a model element level of development is. It is up to the team to write the story with that vocabulary. What I mean by that, you could do design, bid, build, and that would have a different schedule of how the model evolves. You could do integrated project delivery. You could do design assist. You could do design build, and those models would evolve. The elements in them would evolve differently as you brought those teams together. There is no LOD of a whole model. A model is a cocktail, if you will, of elements at different LODs. So never refer to LOD of a model. It's like saying you saw a unicorn. It's nonsensical. Never apply LOD to a model. It is the elements in the model. And a model is always a mixture of elements at different LODs. Some of the lawsuits I see are where someone said, I'm going to give you an LOD 300 model. And what they've written is that everything in it is going to be a 300 by reference. And that's never the case for most situations I've seen. LOD does not match any design phases. There are trends, and we can note those trends, but never fool yourself into saying it's design development, so LOD is going to be 200, or it's construction document phase, so LOD is going to be 300. A model is a mixture of elements at different LODs. It is using the AIA definitions with one exception. Further information on this can be derived from the digital practice guide. In the interest of time, I'm going to go through some of these quickly. You've seen these definitions before. Remember, 100 symbolic for the element. 200, the element is approximate. 300, it is specific. And I'm going to show graphics of these here in a little bit, and I'm going fast because some of the earlier presenters have covered these definitions. I have decided to leave them in the slides, so if you get PDFs of these, you'll have them for reference. 300 is distinctive and unique to the BIM Forum's LOD specification. It was ratified in 2013. I originally authored the proposal for it, and it really was birthed out of some of the early litigation work I had done. It seems like most of the lawsuits I was finding on elements were between 300 and 400. And I'm going to elaborate a little on 350. But 350, if you thought of it in a nutshell, is for cross-trade coordination. And the definition, the key phrase to think about is the interface with other systems. So we'll go into that a little further later. LOD 400 is the detailing level. Jamie mentioned it earlier. I'm going to go through some examples very quickly. What I like about this specification, and this was one thing I advocated for, I wanted a picture on every page. I get tired of reading specs, and a picture is worth, and for so many of these topics of LOD, we use 1,000 words. when we have these very powerful models and we can start to communicate with graphics what we're trying to say that we want people to do in 3D models. It pains me when I see a 30-page BIM execution plan and they spend 1,000 words defining something. So this would be cold form metal framing, and even Ray Charles could see these LODs, and that's even after he's dead. So I'm looking here, we wanted this specification not to be easy to get right. We wanted this to be hard to mess up. We wanted to get this spec where it was very easy to use, and then going the extra mile, that it was very hard to mess up. So we added graphics. So this is a wall. It's approximate. The thickness may or may not be correct. The location of openings may or may not be correct. At 300, I am saying that the thickness is the specified thickness. It's not a nominal 8-inch wall. It is entered correctly with the actual widths. The rough openings are in the actual locations when that wall is at 300. Some design models meet that criteria, some do not. If you don't want to meet that criteria in your architecture firm, exclude it from your base services. In your contract with your owner, exclude that from your base services or show it as an additional service. This is a cold form metal framing wall. You see a lot on masonry veneer projects. 350, you're starting to see the elements for coordination. 400, you would see the clip angles, the fasteners. And these are images from the LOD specification. Let's go into masonry. These were worked out a lot with Jamie and others with BIM-M. And we look at 100. 100 objects really don't exist yet. There is a mass model, and it would be, it's non-geometric representation. So there could be a SketchUp model, and there would be a narrative that says walls in this 2-story mass will be load-bearing, and the rooms will be approximately of this size. Once you get to LOD 200 of the element, then it needs to be roughed out, but it's an approximate generic placeholder. 300, though, those openings must be in the correct location. So some walls will be at LOD 300 and some won't. 350 for masonry here, we're showing the grouting of the cells. Why would that be important? This is coordination with ductwork. This was presented in one of the earlier presentations. 400 is coming into really getting into the detail, and on a lot of projects we would not model the entire building at this level, but for virtual mock-ups we would. So I'm going to talk about water intrusion and some of those issues. So recognize one engineer on our team did a lot of work on these graphics, Eloisa Maya, and then she also worked with Jamie on getting feedback on those graphics. She was not able to attend, but I wanted to recognize her efforts in that. So we've got this tool, computer power is going, we're getting bandwidth, and we're getting a common platform where we can start to show things. I just want to go through some of the things I see on projects, and again, these slides are included. I'm going to go through them quickly. I'm looking at masonry flashing details. I'm trying to think of all the issues that go awry. What's one of the #1 callbacks for a general contractor on a project? Water intrusion. It's also one of the #1 litigation triggers. Yeah, I'm looking at how end dams are working, at flashing details, and how they must be encapsulated. I'm looking sometimes when they're missing. Dealing with how we handle the returns. And these are things that we might have 2D details to show, but there's a better way. I'm looking, this is looking behind one of the returned systems, looking at what it looks like there, and the model doesn't look that way. And so we have to get to this dichotomy between reality and the model. This one's great. The image resolution, hopefully you can see it, and it's not too shiny, but you know, we've got the flashing. I'm going to see, we go forward one. Let's see if I can do this. Does everyone see the flashing and these fasteners going straight through it? Oh man, Why in the world would someone do that? Well, it's because it was on the shop drawings. Right there, going right through the flashing. So we got, you know, this, you can still copy stuff around in 2D details and move it around. But there is this benefit now. One, you can get a visual as you start to see these penetrations. But I think the day is coming where we are going to start to do material checks. Is a fastener clashing with a flashing membrane? And that day is not far away. Why? Computer power is continuing to expand at a very rapid rate. And so we think today the computers will bog down. And I want you all to open your minds and think this is moving very fast. Let's look at this. This would be great for, looks similar. It's just curved at the top and it's sloping at the bottom. We could probably grab our same 2D details, slap them on the drawing set and get them out because it is late and we want to move on and we're out of fee. But the reality is, if you look at that in the 3D world, you know, you can't really look at your weep holes along the length of that arch. All of it is really going to come out at the ends. And if you look at your water considerations at the bottom, they're all going to come out, slope down to this bottom weep hole. And so 3D modeling of this system, this would be a case I might not do a LOD 400 model of all locations, you know, some punch windows up here. But I would say that there is value when you've got unusual geometries, because I do maintain that it is more economical to fix it with a mouse and a keyboard than a torch and a sledgehammer later. And it's funny, when there's problems in the field, we always figure out a way to find time because we're concerned about getting into a lawsuit. And there's this heat that comes on when we're trying to fix it during construction administration. And some of that will take designers, will take us standing up and communicating to owners about schedules, about realistic capabilities of them making decisions and giving feedback to the designers and design changes. There really is not a soapbox here, and I won't be standing on one for a whole lot. But if I come over here, these are real photos from jobs that had been completed, almost. So you're starting to see where people have not thought through how all the systems are coming together. This is an idea that checking is not going on. These are penetrations going straight into the building. And so one would think a lot of decent sized jobs, you've got physical mock-ups. How many of you have seen a physical mock-up fail on the first test? Yeah, and these are expensive. And so, many people will push back on what I'm about to talk about, which would be virtual mock-ups, which I think is right in the heart of where masonry is. And they'll say, well, we still got to do a physical. And what I point out to them is, of course, but maybe get it to pass the first time and think through it. So this was 2010. I want to say we were operating around 8 to 16 gig machines would be an average machine at that time. Multi-core processors. This was Revit. So this was one of the Dallas City Performance Halls, one of the first ones I'd worked on where I modeled the entire enclosure system. Much of the level of development of the elements would have migrated between LOD 300 and 350. Virtual mock-up was done, cocktail of SketchUp and other things. And really with the masonry was looking at items such as working through the coursing and looking at how that goes together. And on this one, there was not a large volume of masonry. Most of it was exposed concrete. For the masonry, we did model all of the blocks. We did segment the models for the different faces, and it was slow and sluggish, but every block was developed. This used steel curtain wall mullion systems, so you had spans going up from 60 to 70, almost 80 foot of unitized curtain wall system. Now the challenge you have in that is the architect originally wanted a 1/2 inch caulk joint, And if you start to look at your concrete tolerances going over 60 to 80 feet, you could have some issues. It did get expanded to 3/4. But one of the challenges that you've got in this is tolerances. And the reason I point that out is all of these models are incredibly precise, but that doesn't mean that they're necessarily accurate. And so LOD means that, yes, they're always precise, but LOD means when I'm at 300, you can measure from that object and it is within its location. I don't need to reference any drawings. I can measure in the model and I know its location. But the LOD spec does not address tolerance. Tolerance is left to each industry's materials. And so when you start to look at things like curtain wall and how they fit around masonry, you can get large thermal expansions. There's live load deflections on the floors. You can start to compound things. And that's where we need to start looking at tolerances. And this is where laser scanning comes in. This in 2010 was one of the first laser scans we used with enclosure systems, coordinating masonry. And this technology has grown substantially. It's faster, it is more economical, the computer power to process it, the turnaround times are quicker. Moving forward to 2012, this is Tobin Center. On this, one of the things was documenting the stonework and masonry work on the project. This was a 1928 structure, and it was exposed. They're adding a $135 million addition to the center of it. And so my team went in, we scanned it. So built up plate girders and all original masonry work, but this is the laser scan. So I could tell you where every grout joint is. I can tell you every aspect of the rough openings, and I can go back and measure those. If there's any measurement I forgot to take while I was out there, I simply open the model and I go and measure it. These are millions of points. Nothing is really modeled here. This is a point cloud of millions of points, and then later we can go and work on it. This is a medical office building. This is a current project that's underway right now. This would be LOD 350 modeling. You'll notice this one happens to be with Revit. So you can see how it's applying that wallpaper even on the top, which is kind of silly. It doesn't even match its own image on the side. So ignore the hatch patterns. But what is going on here, and you would start to see as this gets developed, we're not doing a mock-up of the entire building. We are focusing on where they're going to build a physical mock-up. They're going to build a physical mock-up of curtain wall and masonry of this one whole bay all the way up the building, and that'll be what they test in the field. And what we are doing with this is these images go in. Our engineer has put in sections from the design team's drawing. These are being worked out under the general contractor, which is Medco. And these logos will be for each of the trades. And what we're going to do is actually label who installs what product and their specified material. And we would start to look and step through it. So this would be LOD 350 to 400 of the elements. And you would start to see the sealant joints, and we should start dealing with peeling it back and stepping through the installation sequence, talking about where the fluid applied air barrier and membranes will overlap. One of the things we're going to be doing with this is, in parentheses of each of these steps, we will be calling out which trade installs it. And the goal of this is at the building enclosure review meeting, there are no excuses. It is painfully obvious to the most casual observer how this enclosure system comes together. But this would be a good example, in my opinion, of you going to LOD 350 to 400 on this. We would start to show where the systems would start to feed in and how the brick veneer applies in, stone veneer, etc. Not a lot of time compared to the liability you have if there are breaches or troubles in the system, and also you're not doing this over the entire model. Moving forward, this is the Mobile Courthouse. Yates is the general contractor. Tom, you did some of the glazed block on this project. We had the pleasure of collaborating with you on that. Our company is doing all of the stone from the shop drawings, and this would be 350 to 400. Every stone is modeled individually, distinct to its size, with its clearances. As you go through the entries, what you have in the background here, this is a progressive collapse design blast resistant structure. It has precast panel along the perimeter, steel structure on the interior, and then clad in stone. So what you'll see here is a number of the connection fittings, and part of our task is modeling each of these shelf angles, but they needed to be intermittent to work out with the precast concrete. There were changes during the design. This is on the interior as a separate task. We did handle the CMU, and this is just the extracted grout model. These are detention areas in the basement, so all cells are grouted. So what you're looking at, you don't see the block. This would be LOD 350 on the walls for coordination with ductwork, and this is where the structural steel floor beams would be coming down, and probably ductwork there. Moving back to the exterior, large model, but I will say I think we're running, a number of our machines are been upgraded to accommodate laser scan data, which are large point cloud sets. And this is on a decent desktop, but this is kind of in the $2,000 range. But remember, a BIM year, 1 year of a human life is 30 years in the BIM world. So you need to be thinking, you need to upgrade your machines every 2 years. Be thinking about that. Because 2 years in, they're basically ready for retirement, 65 and a half. Here's the exterior going in. What we then took with this is brought in laser scanning of the precast concrete system. So what you're seeing here, they have not gotten the stonework this far along. This is the laser scan of the precast underlaid with the stone model going around it. And one of the things we're working out, there was coordination error issues between openings between precast shops and the stonework that got validated in this process. And then the laser scan is helping validate the tolerances for the systems. So as I go with this, I'm looking here at my time. I won't have time for questions, but there's a few takeaways. BIM is, I flipped that, it's 10% technology, 90% sociology. And people are the biggest challenge, and they are the greatest solution. But the takeaways here is that it takes a lot of training. If I had to point what's holding teams back today from when I did my graduate work now 20 years ago. 20 years ago, very few people wanted to do it in the building industry, and we didn't have computer power, we didn't have bandwidth, we didn't have common platforms. I would say around 2005, I started to see these things coming in place, and now in 2017, what I believe is holding us back is training. I believe we do, for most firms, if you're a one-person shop, you can afford to buy a computer that can do this. You can afford to have the software, arguably, to do this. And you have the internet connections. If you have kids in high school that do video games, you probably already have the computer and the internet connection to do this. But what's holding us back now is training. And that's one of the things I've been excited to see the BIM-M Initiative with their guides, their examples, stuff that Tom's doing that he's going to show more here later. One of the curriculum, Jamie mentioned this earlier, is the Certificate of Development. There's a lot of free webinars on that, live online workshops. It's in collaboration with BIM Forum's LOD Spec, USIBD, which addresses the laser scanning. It goes to the basics for modelers, and then there's a simple 1-hour exam. I believe it is currently free to general contractors that enter the pilot program. It's also free to students and university students, high school student and university students. It's targeted at beginning but also experienced modelers, because it's going to go over things like LOD and level of accuracy for laser scanning. One of the things that curriculum has, and I've been working on the structural aspect of this, is a sample model for level of development. And it is a medical office building, and that medical office building, this is showing here, elements in green are at LOD 300, in orange are at LOD 200. One of the things I want to point out here, in this level of the design, the elevator shaft hasn't been finalized yet. So those objects are approximate. But here's a model that's a mixture of elements at different levels of development. If you had rooftop units that had not been finalized in their design, then the roof steel there would not be finalized. Those elements would be at LOD 200. And so if you contractually said that you're going to hand over an LOD 300 model, meaning everything in it's at 300, and you were the structural engineer and the elevator hasn't been picked out yet, technically you're in breach of contract, and there is no errors and omissions insurance for breach of contract because it's just a failure to fulfill a contractual obligation. And this is one of the problems I see when people misuse the term LOD. It is powerful, it needs to be used appropriately. The thing I like about this curriculum is the sample model is highlighting that. What NISD and the Certificate of Development curriculum want to do is add in modules. Currently they're working on one steel. They're adding in concrete. They want to add a masonry module. We look forward to collaborating with BIM-M on that. This project in the medical office building is made from real world projects, from real design drawings. And what I'm doing to go through this, the curriculum does include laser scanning. This example here happens to be anchor rods. Some of the other ones I showed earlier are similar to what might be included for masonry. But it's showing the difference between what was design intent. These are not photographs. That is a point cloud in color. There are millions of points that make that out. And in this particular example, it's not just the XY location of the anchor rods off, we're picking up the slopes of the anchor rods. And this is important in creating the remedial base plate details. So you can see how that anchor rod is actually sloping. And then this is extracted from the point cloud automatically using Scan-to-BIM software that finds the surface of the point cloud image and extracts out where the anchor rod is. This kind of technology would be very expensive and take a lot of computer power 10 years ago. Today, you can run this on some of the tablets, laptop devices, and it's going to become more and more ubiquitous. So how you inspect a building will start to evolve. I've seen some people doing pilot work with thermal imaging, looking at masonry walls, seeing which cells are grouted and ungrouted from thermal, and overlaying that color map to the laser scan data. So you have both the geometric representation of where all the joints are and the heat map across the wall. So again, these are just going on from there. David had asked me to go a little fast. I think we have time for some questions. Y'all have been very gracious, and I appreciate your time. If you're interested in the Certificate of Development, I added that. I think the next online live workshop's the 19th. And the BIM Forum, I hope to see some of y'all there. It's in Dallas. Be a warm place to go in November. Easy to get there. There's 2 airports, direct flights from other places, and some pretty nice people, and we'd love to host y'all there. With that, I'll turn it over. Are there any questions? How many of y'all are using the LOD specification on projects? Okay. Very good. How many of you think you might need to moving forward? Okay, good, good. How many of y'all have used virtual mock-ups on your projects? Or heard? Yeah. What was your experience with them, sir? It's very good. Okay. And what is your perspective? Architect, general contractor? Architect? Very, very good. Did the GC do them? Did you do them in-house? What? Did them in-house? Okay. If you don't mind me asking, what software were you all using? Very good. Okay. Anyone else using virtual mock-ups? A wide room. Okay. Of the general contractors here, do you feel like this might be an area you might start looking at with your projects, particularly with masonry in the joints of the virtual mock-ups? Good. Any other questions?
Well,
Yes.
I'm just wondering if the contractors or the architect, engineer, been exposed to BIM.
Very good question. I'm going to repeat it. To architects or general contractors in the room, have you been exposed to BIM execution plans? One here. Okay. Any others? Okay. That's an area I see emerging, and many GCs are starting to work that in their bid documents. Many trades are sometimes in their estimating departments signing those bid documents and not even looking at the BIM execution plan. It does take time to do this level of modeling. Sometimes it takes a notable amount of time, and if the estimating departments do not know about LOD and BIM execution plans, sometimes they will be the lowest bidder, and they'll get the job, and then their project manager finds out later what they bought, and pay-apps will be held up until the models are delivered. And there's a lot of meetings. There can be a lot of meetings, and you've got to attend, and these can take a while. If the designs are not fully vetted out, I know this probably doesn't happen on any y'all's projects, but if you did get a design that wasn't fully thought out, some GCs are having to do what I call design completion. And that's where through RFIs they try to finish the design. And that takes a long time. There's a lot of meetings involved. So you can burn up a lot of hours sitting in those. Great question. I would say the CD BIM curriculum has a sample BIM execution plan that you can go to that website and download. It is used on the exam questions. It references the LOD spec. And one thing that is also in there are sample general notes and specifications. What we do on our design drawings is we include a model level of a development section in our general notes. And we do request that the trades model, they have to deliver on origin. And in some projects, we've requested that the trades provide laser scanning of their scopes of work as that moves forward. So the way in those cases, as the designer, I'm not taking on all of that modeling. It might be a design bid build, and I may not have the fee under a traditional fee structure to do all of the modeling. But that does not mean that the project doesn't need it. It doesn't mean that the pursuit for quality for that owner needs to be compromised. It can simply start to be required. What we do is we require any of the trades have at least one person that has CD BIM on staff, and that is, if I'm doing welding, they're going to have an AWS CWI on site. If they're doing modeling, I want some certification that this person is competent in the models, and that's going to be for masonry, concrete, cold form metal framing, curtain wall, waterproofing, metal panels. I don't want to hear that, well, we don't do BIM, we excluded it, because that's going to be the ones that leak. They're going to be the ones that drill through the flashing. And I might prescribe that GC provides virtual mock-ups in 3 to 6 of the areas in the shop drawing submittal process. There are ways that, regardless of the project, that you'll start to see this trickling through, particularly into the masonry arena. Yes, sir.
Can you describe below which
Good question. Good question. I've seen lawsuits on $100,000 job, and I've seen them on a $160 million job. And so the question is, what size job is valuable to do this? And I am starting to believe that if the job needs to be done right, it's worthy of measuring twice. And that with training, This is not going to bankrupt firms. It's going to distinguish them. But I will tell you that the training is an investment. So with that said, I might spend 20 hours on 10 to 20 hours maybe on one of these virtual mock-up details. And that includes getting the information, modeling it up, having a couple meetings on that condition, and sending it out. There's a lot of components of a building that just don't need that people have been building for years, and our typical details are fine. But there might be some tricky conditions where it's worthy. And so I would think, I've seen some GCs on maybe an $800,000 entry that they're adding to a building that had some peculiar situations on how the new is interfacing the existing. They wanted these virtual mock-ups. I could see another case where it's a simple $5 million ground-up medical office building that maybe you don't need much at all because it's all new and simple systems. Correct. And I bet if we all sat around the table, we could come up with war stories of, give me these 10 buildings, I'll tell you where the gremlins are. I'm not seeing section cuts over here. That's going to be where I'm going to have problems. You can look at the set of drawings and where you don't get a lot of detail in section cuts, that's where I advocate for doing virtual mock-ups. Does that help answer the question? Yes, sir. Let me repeat the question. How much of the fee is used for this level of modeling? Designer or structural engineer or structural engineer? Depends on the market and the location and the project. And so what I could tell you is, let me answer it in hours. I would think it's decent to think on maybe a $10 million building. You could pick 6 to 8 locations that would be very helpful to do a virtual mock-up of, and they would represent the areas you think you're going to have trouble. And it would bring in the trades, and you might be looking at 20 to 40 hours for one of those details. Per detail. Per detail. And that's having the meetings, because the main thing is getting all of the disciplines in. And I'm also including using time to train people who've never seen a model before. We'll take every trade and we'll show them how to walk around a model. Pardon? Some GCs are investing that much. Others just need, this one on this job just wanted 3 of them done. They felt like 3 that can't take care of us. And then the more these are done, the more repetitive they are. Some people do schools. I know one designer in our market, I can just drive around and I can look at their schools because they use the same details on school after school. And you can see their masonry work and you know it's them. They would have repetitive nature in those. And there's probably value in doing that if they were looking at a new design feature. And then the tools are getting faster. Some of the simple ones, if we're modifying them, you might be looking at 8 hours to work through one of those details. We typically export out all those images to PowerPoint. And the reason is in the building enclosure review meetings, that lets whoever's facilitating it, most of them know PowerPoint, and go and add notes and add comments. So much and such needs to install here. Yes, sir.
What software are you using?
We use a cocktail. Some of the ones you saw here were SketchUp. Most of the ones you saw through the body of this were Revit. And then on some occasions we'll use Veneer. Previously used Tekla. We've now moved over to Autodesk products. There are a lot of good options between any of the big platforms out there. When people learn the tool, they can make this work regardless of platforms. Any other questions?
So when you do these, you don't have the trade committed. It's a little bit of questionable.
It does. So the question is, what do you do when the trades are not committed yet? It's a great question. Most GCs are starting to, they're taking the lead in this process, and then as they bring the trades on, they're working them into it. So some of this is happening. Concrete has already been bought out, and some of the enclosure trades are still being brought on, and a lot of the masonry contractors in our market, we're doing the modeling for them. And some of them have started to internalize the modeling. But again, that depends on firm size. But regardless whether you're going to bring modeling in-house or use a consultant or third party, I feel like everyone needs to understand it. So that most GCs are starting, that we work with, are starting to require this certificate of development. So the masonry contractor at least gets a baseline training, even if they're going to use a third party to do the modeling for them.
But that would be a good reason for saying those drawings, subcontractors.
You're talking about the detail. It'd be a good reason to assign it to the trades to have the higher levels of development in the models. And a case can be made for that. Because I know in our firm, when we look at hiring even interns, yes, I look at GPAs, yes, I look at a school. I'm also looking, did they ever touch a hammer? I don't want to hire any engineer that has not spent some summers working in construction, because there's too many designers that don't know how buildings go together. And they're modeling and they're making pretty pictures and they're very precise. It's just they're 3 feet in the wrong place. And so there's always this tension of precision versus accuracy in the model. And that's where LOD comes in. When you say it's 300, it's in the right place. 350 means you've worked out that trade level information. And you're exactly right. You need to have wisdom from people who build things. I think we'll end it there.
Thank you. Thank you, Will.
My pleasure.